Sumitra Kamalanathan and it's GE8291. And today's topic of discussion is chapter 2, which emphasizes on an in-detail discussion in the understanding of the environment and its components. I will be splitting this chapter into many short videos, especially for the layers of the atmosphere. You might ask me, why am I doing so? I need every student to understand the chemistry behind the atmosphere in an elaborate way so that it will be useful to understand global warming and related research when it is up for discussion. After finishing this video, the objectives you will be able to achieve is define environment with two more definitions, define biosphere and its components, define atmosphere and define functions of environment and atmosphere, appreciate the selected properties of the Earth atmosphere chart based on which the layers of the atmosphere are separated. The layers of the atmosphere will also be dealt as 5 videos without clumping it all together, as I want you to understand the chemistry behind each atmospheric layer, as it will be helpful to understand global warming in a better way. In the previous chapter, we had defined the environment as per the Environmental Protection Act of 1986 and as per the definition of environmental scientist Gowdy. In this chapter, we will appreciate 2 more definitions of environment proposed by scientists P. Gilbert and Boring. As defined by P. Gilbert, environment is anything immediately surrounding an object and exerting a direct influence on it. As defined by Boring, a person's environment consists of the sum of total of the stimulation which he receives from his conception until his death. Thus, having defined environment in detail, the next topic of discussion would be on the components of the environment. The environment mainly consists of biosphere. The biosphere indicates the realm of living organisms and their interactions with environment and encompasses all the components of atmosphere, hydrosphere and lithosphere. Having understood the main components of the environment, now let us get to discuss each component separately. The first on our topic of discussion would be the atmosphere. Understanding the atmosphere structure in detail will be mainly needed for understanding the chemical reactions involved in global and warming and will help you to design novel technologies to combat global warming if it is your future destination of research or green technology ventures. The atmosphere of the Earth is the layer of gases surrounding the planet Earth that is retained by Earth's gravity. It has several functions such as the following. It sustains life on Earth. It saves the Earth from hostile environment of the outer space. It absorbs cosmic rays from outer space and a major portion of the electromagnetic radiation from the Sun. It will transmit only ultraviolet visible near infrared radiation spanning between 300 to 2500 nanometer and radio waves 0.14 to 40 meter, while filtering out tissue damaging ultraviolet rays below 300 nanometer. The Earth is the 3rd planet from the Sun. The Earth's distance from the Sun is 149,600,000 kilometers. This distance from the Earth to the Sun is called an 1 astronomical unit that is used to measure the distances throughout the solar system. You will be able to appreciate the importance of the unit when we start our discussion on global warming, solar flares, why it is important for us to discuss solar flares, and how anthropogenic activity on the atmosphere is weakening and how it is incumbent only on us to rectify the mistakes ourselves by furthering green technologies, which will be presented to you through our case studies. Earth is the only planet known to have an atmosphere containing free oxygen, oceans of liquid water on its surface, and of course supports life. Roughly 70% of Earth's surface is covered with water, most of it in the oceans, and 30% of Earth's surface is land. The atmosphere of Earth is the layer of gases that protects the Earth from the radiations and cosmic rays coming from the outer space and sun that is retained intact by the Earth's gravity. This atmosphere acts as a blanket because it keeps average temperature of the Earth nearly constant by not allowing the harmful radiations to enter the environment. Beyond the stratosphere, on the basis of temperature, scientist S. Peterson has divided atmosphere into 5 layers. These layers are the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. This classification of the layers of the atmosphere was done on the basis of chart that was based on the selected properties of the atmosphere extending from the surface into space. Imagine yourself standing at sea level and looking up through the atmosphere. The first thing we can do with this chart is we can use it to measure altitudes using either the mile scale with increments of 5 miles or kilometer scale with increments of 10 kilometers. The rest of the chart is very helpful as it shows us things like temperature, pressure, and water vapor concentration changes as your altitude increases. Understanding this chart will help you understand the chemical properties of the layers of the atmosphere and global warming. So let's first understand the chart. First, let's start by looking at the 4 main layers of atmosphere, starting with the troposphere. In the troposphere, as you rise up through the atmosphere, the temperature drops off sharply, but then you hit the interface or the boundary called the tropopause. And once you enter the next layer known as stratosphere, and in this layer the temperature actually heats up, then you arrive at the stratopause and pass into the next layer called the mesosphere. And here the temperature once again drops and goes way down finally. When you reach the top layer known as the thermosphere, where temperature rises again until you eventually reach space. From this chart, we can also tell how the air pressure changes, and as you can imagine, as you go up through the atmosphere, there is less and less air, and so that pressure drops off steadily with altitude. Similarly, as you go up, the water vapor concentration changes. It gets much less as you go up through the troposphere. In fact, above the tropopause there is virtually zero water vapor. If we step back and look at the chart as a whole, there are a couple of things that we need to be aware that aren't included in the chart. These are the information of the chemical reactions and properties of each layer of the atmosphere. So with this chart, I come to the end of this video session. The next video will emphasize only on troposphere and tropopause in detail, so that you will get a good idea on the layers of the atmosphere before we start discussion on global warming. Understanding this chemistry will help you to design novel ideas in combating global warming, We will end this session with the remarks of Albert Cesar and Georgi. Research is to see what everybody else has seen and to think what nobody else has thought. Thank you for listening to this session of the 8291. I hope you will join me back in the next video. Thank you.